Venus Aerospace has reported successfully testing its rotating detonation engine, RDE, on a small drone over the United States. Conducted on February 24, the drone flew at subsonic speed for over 10 miles, 16 kilometers, proving the technology. The new engine promises hypersonic travel, rivaling efforts from other nations like China. RDEs offer high thermodynamic efficiencies and compact design, making them promising for propulsion and energy systems in the future. For this reason, various nations are working hard to develop them. China, for example, recently reported having developed one that could, in theory, reach Mach 16. Japan reported making good progress with its RDE back in 2021. Raytheon is also working with the U.S. Defense Advanced Research Projects Agency, DARPA, to make one called Gambit. However, RDEs work very differently from conventional engines, like rockets. In a typical rocket engine, propellant and oxidizer are mixed and ignited in a combustion chamber to produce a powerful exhaust plume. RDEs, however, work using a wave of detonation that travels around a circular channel. Venus Aerospace is working with DARPA. This detonation wave is maintained by the injection of fuel and oxidizer, which produce a shockwave that moves outwardly at supersonic speed. Like Raytheon, Venus Aerospace is collaborating with DARPA to develop a device for hypersonic technology testing. The 8-foot-long drone, which weighs 300 pounds, 136 kilograms, flew at an altitude of 12,000 feet, 3,658 meters, at Mach 0.9. The engine was powered by hydrogen peroxide, pushing its monopropellant engine at 80% thrust, not to exceed Mach 1. The engine produces around 1,200 pounds, 5,338 newtons, of thrust with a 4-inch, 10-16 centimeters firing ring. The drone was dropped from an Aero L-29 Delphine aircraft. This engine did not undergo full thrust during testing due to the limitations of the unspecified test range in the United States. The location, Venus Aerospace explained, did not permit supersonic flight testing. Following the test, Venus is confident it could combine its RDE tech with air-breathing technology. This involves using the engine's forward motion to ingest air for combustion, resulting in a rocket-based combined cycle engine. The successful development of this engine would enable Venus to achieve excellent performance across a wide range of altitudes and velocities. While this idea has mainly been theoretical and studied at universities rather than pursued for commercial purposes, Venus is now taking steps to make it a reality. RDEs are the future. The test demonstrated successful flight controls, stability, telemetry, air launch, and one leg of the ultimate rotating detonation rocket engine, RDE, propulsion system and ground operations. Using an air-launched platform and a rocket with wing configuration allows us to cheaply and quickly get to the minimum viable test of our RDE as a hypersonic engine. The team executed it with professionalism and has a wealth of data to anchor and tweak for the next flight, said CTO and company founder Andrew Duggleby. This is how you do hard things, one bite at a time. Up next is RDE flight, and ultimately hypersonic flight, proving that the RDE is the engine that unlocks the hypersonic economy, said CEO and co-founder Sarah "Sassy" Duggleby. Venus now plans to develop a larger 12-foot, 3.7-meter test vehicle that should be ready for testing by 2025. This larger platform should be capable of Mach 4 or 5. Venus's longer-term goals are to develop a large Mach 9 vehicle and a Mach 2 plus commercial passenger RDE-fitted aircraft.